1997 Dodge Grand Caravan or Caravan. Customer complaint with this one is randomly lights on the dash, electrical stuff wouldn't work correctly. I know she has a window issue with the passenger one, I believe. So you gotta look at some of that. So I already scanned it once about a week ago. I've been so busy, I haven't had a chance to work on all these cars out here still. Gotta do this van, this Crossfire, this Range Rover, Camaro, Dodge Diesel, a BMW, an Altima. So this is one of the shops that means, well, this is actually Steve's shop. So we've been pretty swamped. So what I'm doing a full system scan here. I got nothing right now in the engine computer, but a few days ago I had a Chrysler collision detection CCD bus, 2 codes in there. I can't remember what they were, but I don't know if they were like J1850 variable pulse width. Don't quote me on that. I just know there's CCD bus issues. CCD meaning Chrysler collision detection, not meaning collision in the vehicle, but collisions of data information. So what they use is Chrysler collision detection high and Chrysler detection low, high and low. It's for module to module communication. Your SCI bus is for your PCM with the diagnostic tool. Again, CCD is module communication, and your SCI bus, transmit and receive, is going to be for your how you talk to the computer, the PCM, and for module programming. So let's see here. And I'm not even on the network for the topology. Anyways, see what modules. No, nothing with the, nothing's responding except the engine control module so far. And I would think there would be more than one module on this. I could use the DRB3 emulator with the MicroPod 2 I have with 2, but I would think there should be, we should be able to at least talk to the instrument cluster as well, and maybe the radio. I'm not sure. It's an older vehicle. Like I said, it's a 97. So we'll see. We could always hook up the MicroPod 2 with the DRB3 emulator. But we should be able to talk to the ABS, I would think, too, as long as it has it. And the airbag. It has SRS, supplemental restraint system. So let's let it finish in scanning here. Yeah, turn on the radio. Yeah. Let me let it finish scanning. All right, it finished scanning. No response to any module except the engine computer. And I had that code in there before. Maybe we got to drive it so many times for that code to come back up. We may use the MicroPod 2 with the DRB3 emulator to see. But what we should have talked to, because I got this from the service information, we should be able to talk to PCM, which we can. Overhead console. I don't think this has an overhead console. No, it would have been up here. So it doesn't have that. Transmission control module. We can look at that. That may be part of the PCM, or maybe separate. It says EATX, electronic transaxle, or something like that. ABS we should be able to talk to, which we're not. Radio we should be able to, we're not. BCM. And junction block, it says. Instrument cluster and airbag. We can't talk to any of those on the CCD bus. So I want to scope that and look. Let me hook up the DRB3 emulators and MicroPod 2 just for another source. And then we'll have to scope this bus and go from there. Alright, so I looked at an older text message of mine, and the customer said that the gauges, the dash lights, the wipers wouldn't work, and then sometimes they would work, which would make sense because that's on the CCD bus. So I got the MicroPod 2 hooked up with the DRB3 emulator, can engine off. See if we can talk to this thing here. I'm having some issues with my pod that I've been taking apart trying to help somebody out, and I got 2 of these and I've been putting back and forth together, so make sure this thing's still good. So we're going to go to number 2 because it's a 97. We're going to go to number 1. It's going to open up another tab. Go to 1. Hopefully this works. My green little lights on our micropod 2. Usually on the micropod 2 and the DRB3 emulator, I usually like do 98 and newer. I've only done a couple this old, I guess, with the micropod 2 clone 2, and then the yeah, there we go, and the DRB3 emulator. Let's go to engine, make sure we can talk to it. Should tell us our software part number. Then we know that our pod's working, software's working. We know we can talk to the engine computer because we did it over there with the Ultra. Come on. There we go. There's our parts number. Thank God. It's got auto trans. Yep. Hit enter. Let's go to 2 for test. Read DTCs. Okay, no DTC. So we know, which we didn't see that earlier, or we didn't have codes with the Ultra. I did before when I read this vehicle. But let's go to body. What is this thing doing? No, it's a little slow. It's probably going to have a no-com, because we would have been able to talk to it with the Ultra. Should be no-com. We'll do a couple other modules just to confirm this, because this DRB3 emulator, this is the DRB3 Soup. What the heck? We can read it. Mechanical Mister Cluster must be working now. That is weird. Okay. Let's go to display. What module are we in? Oh, it's because I hit the cluster. I went to, let's go back. Let's go to 3 body. Let's go to body. No com. That's weird. Let's go to 3. No com. We just had com, which she did say comes and goes. Let's go to ABS. I don't know why the thing was flashing like that, strobing. I was having some issues with this when I was plugging in. The light would turn on, or it wouldn't turn on, and it finally did. And I think it's not a hardware thing. I think it's just a software thing. It's got to go through its circuitry and stuff. Trying to talk to the ABS, which we couldn't with the other scan tool. And we could talk to the instrument cluster for a little bit, and then we couldn't. So we got to look at that CCD bus, Chrysler Collision Detection Bus. And we finish this up here. So I finished up no com. Passive restraints. Let's go to airbag. No com. Let's go to 1. Let's go back to engine. Or we can talk to the engine, because the engine is not using CCD bus. I mean, it is to talk to other modules, but we're using the SCI bus to talk to it. Let's just see if there's any DTCs. No DTCs. See if there's any information in here. So let's go back to body. Let's go to the instrument cluster, mechanical, no comm. But we did earlier, which is so weird. Let's go to the electric one, same thing. It's not gonna have electric anyways. Instrument cluster. Chassis. Nope, none of those. ABS. It's gonna be a no comm. So just wanted to prove it with this. We did have comm for a little bit on the mechanical instrument cluster. But we're just validating it with another scan tool, obviously the Ultra, Auto, Micropod 2, and the DRB3 emulator. Still trying to, there we go. No comm from the brake module. Okay, which is expected. Alrighty, before we go any farther and look at the CCD bus, let's go back to our diagnostics. And let's go to ABS and pause it, see if we can get comm again. Because sometimes I would get it and sometimes I wouldn't. But I'm not always catching it on camera. Let me see if I can get it again. We'll see what happens. Alright, no comm again. So I found something in here. If I go back to vehicle module scan 4, it's going to scan all the modules that's on this bus. Now it's scanning the engine. And I scanned them out earlier, and I'll show you what it comes up with at the end result. Takes a little bit of time, like 3 to 5 minutes, maybe more towards the 5-minute side. So it's scanning the engine, now it's scanning the transmission. Now it's scanning the BCM. So I'm going to finish through all these modules, and I'll show you the last screen what comes up before we go any farther. It's continuing the scan. It's on the memory seat now. I did brake, so it's like the auto scan and the auto, I guess. It's where it's looking for modules on the bus that are active. Now it's doing door, but I'll show you what comes up when we're done here. Alrighty, it's done scanning, and this was what it shows us: vehicle module scan, engine, BCM version, brakes version, airbag version, and mechanical instrument cluster version. So the two with the asterisks, if it had asterisks, said there's codes in there from the previous screen. So if I go to the BCM and hit enter, which why can't we talk it on the other side of the scan tool? I'm not sure. Maybe something with this bus issue. Talks to the version, country, model year. Okay, let's go down to read ETCs. ABS message not received. Front wiper park switch check open. Okay, we never had that before. Lost comm and it came back. Lost comm and it, yeah, so that's there. It's coming back and forth. There's definitely issues with this bus. So yeah, you can see it there doing all that stuff. Let's go to input output display. This thing's slow, but there's some live data. Never had that before. Let's go to the brakes and see what we got. Man, this glare's bad. Let's go read DTCs. CCD communication. There we go. Brake. CCD communication. 2 occurrences of diagnostic trouble code. I don't know what that crap is, but there we go. Alright, so what we're going to do now, I'm going to hook up the Ultra one more time. which we're not going to have comm to it, I'm sure. Let's just look at it one more time, and then we're going to go after the CCD bus and scope it. All right, so I pulled the MicroPod 2 out. I'm using the Autel again, Ultra. And let me start this over because I didn't get a Bluetooth right away. I didn't get it hooked up right away, so I wasn't talking to the VCMI. Let me reset this and we'll scan it again. All right. Now we're going to redo it here. Man, these older Dodge Chryslers are so damn slow with the Alto. And Ford too. All right. Full system scan. Okay, engine's good. Let's just let it scan through everything and see what we get. All right, we're continuing to scan here, but the only thing we can talk to is the engine computer. Mechanical convincing cluster, no. BCM, no. We're not going to have comm in any of this. So, we can't talk to it on the CCD bus because it's down. We can't talk to it with the DRB3 emulator with the MicroPod 2 because it's down unless we do a test. There must be some software in that DRB3 emulator that pings the modules and they respond, right? So what our next step is we need to understand how a CCD bus works. There's a good video on YouTube I'll show you. And I showed you guys another video on my YouTube of troubleshooting another vehicle. I got to finish it up. I only did part 1 on a Dodge truck where that CCD bus, but we were looking at the SCI bus. It's dead on Diagnostics. Well, that's Phil Collins right there, but we'll get that pulled up. Go over how that works from his video, and then we'll start troubleshooting. I'm going to pull up the video here in a minute. Here's the video right here.
This is Chrysler's collision vehicle crash. Is collisions of data.
Let me rewind that so you guys can hear what he said.
This is Chrysler's collision detection. No, this doesn't have anything to do with a vehicle crash. It is collisions of data. It's a multiplex network using multiples modules. It's used for scan tool and mobile and module-to-module communications. It's got a 7812 baud rate. It's very noise or EMI tolerant, electromagnetic interference. This is because of a twisted pair. It's very much like and very much akin to CAN. Now, the modules, the drivers have a bias that places a voltage on each wire.
All right, so I'm gonna go over parts of this video. He's got awesome stuff, so we know how we can hook it up correctly, and we got to scope that bus. So if you listen here,
go look at it live so you can see it. Want you to understand something very specific about this, and it's very important to understand how we hook our scope up. We're trying to make sure you understand their data burst taking place here.
If you look, his voltage is only like 250 millivolts. So in this video, he's shown there is a twisted pair for CCD plus and CCD negative.
I guess it's white and black, whatever. The differential on each side of the twisted pair. And this is very important for you to understand this.
Next part's
important.
By the way,
this does have a good junction connector. Here's what it looks like when we go to test it. We're going to hook our scope up in a very specific way. We're using one channel. Let me say that one more time. We're using one channel. Both sides hooked to the scope, hooked to the CCD circuit. In this diagram, you see it's on the red. The plus is going to pin 3. The black is going to pin 11. You do not have to have the scan tool connected in order to see communications because this is intermodule communications. Now, we're just...
All right, so I'm going to hook my scope up with one channel, positive to pin 3, negative to pin 11, using my oscilloscope. One channel. And if you look on our wiring diagram, to our DLC. Should be the same. Yeah, 3 and 11. 3 is negative. 4 or 11 is positive. I might have did that wrong. Hang on. 3 is negative. And then 11 is, well, I don't know how they're doing that. It looked like this was going, they're all connected there. That's kind of weird. So let me look at that again. 3 is going to negative. And it comes down there. Goes to negative. And 11 is going to, well, still going to those, but it's going down here to positive. It's all connected. We're just going to follow the video and look what it looks like. The way it's hooked up. He wants 3 on positive, 11 negative is what he wants. 3 on positive, 3 positive. We'll have to verify that. Yeah, we'll verify that. We'll get it all set up here.
This is what we get. If you look at the very small squiggles, it's a meaningless waveform. You're going to get about 2.5 volts, and it's going to sit there. That little squiggle is the data. You just can't see it.
Same thing right here.
But if you use differential, when we're telling you, we get this 284 millivolt signal. What size did I say? I said about 284 millivolts from 0 up to 284.
So, right now I'm on a 5-volt scale. Doesn't look like much. I got red in the pin 3 and black in the pin 11 with my breakout box. We're going to change our scaling to a 0.5 volt. And let's go our time base faster. Put a trigger. And that's our message. And he's saying 284, which, yeah, I mean 276, 300. Yeah, it's about right. That is our message right there. Let me inverse these leads and see what it looks like. Or flip them around the polarity. When I flip them, it just goes the other way. It just goes negative 284. Okay. So that's all that does. Let me flip them back. So that's the positive, negative on the CCD bus. We're just flipping polarity. Key on, engine off. I mean, according to his video, that looks pretty good. We need to look at some more data here. So our waveform looked pretty good according to that video. However, I tried to go to the instrument cluster and I still have a no comm. So that bus looks good according to his video. However, it's still, we can't communicate. Now, what he's talking about here, just listen to this part.
Remember, we're looking at the whole world. We can use the voltage to minus in 11. We should get a good signal. This is what it'll look like. And the only difference is if we come up wrong, they'll be inverted. But it just messes with your mind.
Which we saw.
So what happens if this signal doesn't look good like this? What do? If the signal isn't correct at pin 3 and 11, remember, we're looking at the whole world. We can use the volt.
Now he's just saying to check for the bus positive 2.49 volts, plus negative 2.51 volts. Well, I'm doing that right now, which I don't think we need to do, but pin 3 to ground now. your bias voltage from the modules on the bus. I mean, he's pretty specific on his numbers, but it's like 2.51 right in the middle. Let's go to bus negative, or pin 11, the other one. And there should get our bias voltage. Maybe there's our issue. Hang on a sec. 2.5. 2.48, 2.49. Well, that doesn't look right at all with these squiggly lines in there. That's going from the top of that to the bottom of that. It's a half a volt, 455 millivolts, which isn't right. And that's on pin to ground. That's on pin 11 to ground. And if you look, this guy's videos are awesome. 11 to ground, which is a neg. I can't remember if it's positive or negative on this, but it doesn't matter. You should get around 2.5 volts steady, and we're not getting that. So listen to a movie some more.
To see if we have contact at the termination resistor. Do we have 249 on the positive bus? Do we have 251 on the minus bus? That tells us that at least we have termination resistors. And remember, only two modules have termination resistors. The instrument cluster and the PCM. Either one of those connected and we have bias. If they're both disconnected, we don't have bias. By verifying the bias, we know that at least continuity to one of the two. We're not sure which, but we know one of those two are hooked up. So now we're going to have to isolate the modules. But remember...
All right, so let's do that again. He's got some good data in there. Let's go to pin 3 in ground. And you should get a good bias voltage. Go to a 20 volt scale. Just let me see, look at it easier on the eyes maybe. Right? Then let's go to the other scale. Not the other scale, the other pin. 3 to ground. 11 to ground. There's a lot more noise in there. So if I go back to this 5 volt scale, yeah, look at that. That's the, look at all that hash up and down. It's not steady voltage. It's steady and then it goes away. Well, if you look at the other pin, 3, there's a little bit of hash. Not as much. I don't know if that's a problem or not. Now let's just check these like we were at the beginning. 3 across 11. Which we got to change our scaling to a half a volt. Put our trigger on. Let's just change this back. So I can't really tell nothing out of the ordinary on this. Let's add bias voltage. Is it because of the different heights maybe? Maybe that's what's causing it? Like, and I'm just talking loud, perhaps. You got 2.49 to 2.51 and you got a difference, and that's how you're getting your differential voltage on this bus. Maybe they should all supposed to be even, but there's different heights, and the computers know that, or the modules know that. I'm not sure. Let me check something. From the top height down to like there. Yeah, like 285. the difference of that. So maybe that's our issue. Let's change the scale one more time to like 10 milliseconds. Yeah, look at that, different heights there. Sorry about that, I had to answer the phone, but yeah, different height from there to there. Now, is that causing our issue? I don't know, maybe. I mean, difference of 286. But yeah, they're different heights, and I don't think his video showed them in different heights. Maybe that's why we're having issues. What we could do, he's saying IPC instrument cluster is one of the term resistors in the engine computers, one of the term resistors. You know, maybe we gotta look at the network, which is right here, and see. Oh, come on. You know, your engine computer, your powertrain, they go to these, not really splice points, they're all connected together. Not like on the newer vehicles anyways. You know, they're all twisted pairs, but they're not like a joint connector or nothing. There's these connectors there, but I guess we can measure across the bus. Unplug. Get unplug. We can measure across the bus there. We can unplug it up here and measure across the bus and see what we get. So let me do a little bit more research and we'll go back and see what we can figure out. Again, only the IPC and the PCM terminate the circuit. And we verified we got our voltage on positive and negative. However, one of them was real squiggly. Didn't look correct. And you got a 120 ohm resistor on one end and a 120 ohm resistor on the other end. Put them in parallel, you should get 60, less like a CAN bus. And I have the battery unhooked. I'm across pins 3 and 11, and I get 60 ohms across the bus. When I have the battery hooked up, of course, that chain is all over the place. So that tells me my term resistors are good, and if they weren't good, according to him, we'd have 5 volts on the scope, and we didn't. We had the right voltage. If there's any issue with this, that's a bus issue, which we have CCD bus codes. I saw them earlier before I filmed. You guys saw it with the DRB3 emulator. And then we're going to have communication issues between modules. Perhaps it's with that, on the scope we saw with the squiggly lines on the bias voltage. So we got to, there's more troubleshooting to come. This will probably just be part 1 for now. I always say that. Maybe there'll be another part. Who knows where this will take us, how long it'll take us. The customer wants to keep going and go from there. All right, I hooked the battery back up. I want to do another check. So if this, I got my scope hooked up. If it was shorted to ground, the bus, high or low, it would be to 0 volts. If it's shorted to a voltage or, you know, 5 volt, 12 volt, it would be shorted. You'd see that on the scope. We don't. We just see the different heights, and we check the single lines. We see a little anomaly in there. Now, what I want to do is I still have my breakout box hooked up, and I have my MicroPod 2 hooked in line with it. I'm going to go in here. I'm going to talk to these modules and see if anything changes on the CCD bus while I do this. Not that it will, but let's just see. Trying to film and do this. Damn it, I went too far. If I notice something out of my eye on the scope, I will show you guys and talk about it. Let me slow this down. Come on. All right, so let's go to ABS. Trying to talk to the controller. It went way down in millivolts. It went down to 200. Could have sworn it was up here, yeah. What, we can talk to it now? Re-DT. I never got into it that far. So I can talk to it now without doing the self-test on here. CCD communication, 2 currents of DTC. Okay. We want to erase them? Yes. We couldn't talk to it earlier. There are different heights. May back out of this. Okay, watch this. So, I'm going to go into the ABS, which is 5. Watch the scope here as it changes. Right now. Still high. Well, earlier it went down the low. As soon as I got into it, hit that button, it went low down. Instead of 284, 300, it went down to 200. Now I can't talk to it again. I would have been able to talk to it now. But when I went into it earlier, this went from 284, 300 down to 284 to 300 down to 200. And then when I exit out, it went back up. But I'm going to have a no com. All I did was erase the codes. You have a no com. What happened? It just kicked me out. Hit 5 again. Can't determine the controller type. It's so intermittent. Well, intermittent as coming back to work. It's always not working, it seems like, more than it is working. Let me pause this while this catches up. Should be catching up soon to say a no com, but that was weird because that's the first time I had com going into this menu this way. And had CCD bus codes, which we saw with the other when it pinged the modules, basically. Yeah, no com. Nothing changed. Let's go back. Let's go body, which is 3. Let's go to 3, mechanical and instrument cluster, see if anything changes. Nothing. There's a no com now, and it's doing that weird crap again. We just had it, too. No BCM. When I talked to it, this went down. Huh. Let's check. What did I do? I don't want that channel. Let's go to a 5-volt scale. There's your message. Just check our. We'll go to ground. On 11, not 11.3, I mean. There's some noise in there. And let's go to 11 now, to ground. Why is it doing that crap? There's a lot more noise. I think that's our problem. That should just be 2.5 volts steady state, according to what we're watching. And it's worse now, we have no com. We turn the key off. Goes away. Well, kind of. Turn it back on. That's just our bias voltage. There's all that noise on there. Which is on pin 11. We go to pin 3 to ground. There's some noise, but not as much. When you do them differentially, like you're supposed to check the bus, 3 and 11, you change your scaling to a 0.5 volt, you get different heights, which is about 284 millivolts. And then we can't talk to the thing. We did once, and then it went down from 284 to 200, and it had codes, and now we can't get back in there. Let's go back and try it again. ABS. It's not going to talk. It's going to have a no com. And I believe it is because of our bias voltage on pins 3 and 11. I believe 11 was worse. And that's coming from Well, either the instrument cluster module or the engine control module, because that's where the bias voltage comes from. I guess it could be somewhere else on the network causing that. I guess it could be. So what a guy could do is unplug one module at a time and watch. You could watch this one, make sure they get to the even, so they're even. Or you could just watch pins 3 or 11, more than likely 11. Watch 11 to ground, 3 to ground, and or just 11 to ground. Unplug one module at a time, make sure that voltage comes back straight line. And if we find it, then we know what module it is. That's what we end up doing. Yeah, there's no comm right now. So if I go back to this, go 5 volts. Three and 11. A little bit of noise. Oh, sorry, it's 3 and ground. Now we're going to go 11 and ground. A lot more noise. If we unplug one module at a time and we see this go away, just a straight line at 2.5 volts, then I bet you we can get comm restored. I'm thinking that's what our issue is. And then we'll be able to talk to the modules. I turn the key off. Modules are shutting down. No. Turn key on, engine off. Let me just start it. Yeah, that's 11. Go to 3. 3's better. 11's bad. Flip these around. Change our scaling. And they're different heights, same as before. Go back. ABS again. And we had comm one time on video here, and when we did, it went from 284 down to 200 and got colds. That is what's wrong with our, something on the CCD bus. Whether it's a module taking it down, a connection issue or something. Seems like a module issue though. Yep, no comm as expected. So, make sure we can talk to the engine computer. I'm sure we can. If anything changes on the scope, I'll let you know. But we're going to have to come back to this another day and make another part 2 of the video for unplugging modules, which there's not that many according to the diagram, and isolate this network and see what our issue is. You can see this 6 and 7, well, they were flashing there because that's your SCI bus. Scan to a communication. Yeah, we can talk to the engine computer because it's got its own bus. See if any codes came back. No codes in there. Let's do one other test here. Let's just do key on, engine off. Instrument cluster has been working for me so far, but go back. 4. We're going to scan the bus, the CCD bus, and see if this changes anything on our scope. Scanning the engine right now. Let me pause it till we get some more data. All right, just scan the transmission and the other model. And look, I didn't catch it, but it dropped down. It was scanning up here, and then it dropped down. So it was at 284. Let me show you that as that. If I can abort this, press the key to abort. And let me start it over and see what I'm seeing here. Go back. It's still down. Let me go back again. Why is it down to 200 now? Okay, well, it just went, God, I missed it again. It just went back up. Go back. So I'm going to do the same thing. I'm going to scan it. Scanning the engine. Watch it now. So it's doing engine. It's up at 284. Still doing engine. Still doing engine. Transmission, then it just went down. See that? When it's starting the transmission. Now it's doing the BCM, it stays down. Let's just let everything stay down. We'll let this final scan do while we're scoping it, and then we'll read the final data. It's still scanning. It's still down to 200 millivolts. Should be getting done soon here. So when we're done, if it has an asterisk, it says DTC is present, which we did for that CCD bus. This is definitely going to be an interesting one. It's almost got to be something in the engine computer, the instrument cluster, because they both have termination resistors, or another module on that bus causing this, trying to talk when it shouldn't or something. I'm not sure, or wiring, but I don't think it's wiring. I think it's a module issue. We just got to find it and put the time in which is going to take some time. Well, we just unplug one module at a time, and if that goes better, like I said, then we know. Come on, computer. All right, it's done scanning. Voltage is still down. Let's go. There's no codes on any of these now because they're all clear. Let's go to airbag. Let's go into the airbag module. They read it there. Voltage is still down. Let's go read DTCs. Active. No DTCs. Okay, we've never had that before. Let's back out. So now we can talk to the damn thing again. Go back to regular diagnostics. Look, and the voltage went way back up as soon as we exit out of there. Let's go to body. Once it catches up. Now look, it went back down. Let's go to mechanical instrument cluster, which is 3. It's still back down. If we can talk to it now because it's down. Maybe not. Yep, we can talk to it. What the heck? Okay, so let's do this. Let's look at this. 11, our bias voltage. Let's change the scale quick. Still got that crap in there though. Let's go to 3 to ground. Not as bad. Same thing. Okay, let's just watch our bias voltage and read DTCs. Number 2. No DTCs detected. Okay, let's go to 3 and 11 again. Well, we got to invert it. For our differential voltage, 0.5 volt. So they're reading good at 200 millivolts. Now we can talk to everything. It seems that way anyways. Let's go to ABS. Look, I went to ABS and it goes right back up. We're going to have a no comm, I bet. We'll let that finish out. So I just finished no comm. Different heights again. So what we need to do is I need to get in the schematics like this for the CCD bus and unplug one module at a time. It doesn't have an overhead module. We'll start the ones without the term resistor. Unplug the airbag module. See what if it gets better or not. The radio. Body control module. The ABS module. And then we can go after the PCM and the IPC. And determine if one of those modules is taking it down, and then we'll go from there. So that'll be part 1 for this video. Part 2, when I get some more time, we'll troubleshoot it. Like I said, we got tons of stuff going on in different shops here in Mountain Home, Idaho. So yeah, more to come for this 1998 or 7, nope, 1997 Dodge Grand Caravan.